This will shock you, but for a guy who's really into deep math, I was a slightly insular, nerdy child who enjoyed playing. There's a game in Britain called Championship Manager. Loved playing that. Like all teenagers, was like, I want to write my own video game.
That is Paul Battisson, Chief Operating Officer for Cloud Galacticos. I'm Josh Burke, your host for the Salesforce Developer Podcast, and here on the podcast, you'll hear stories and insights from developers for developers. Today, we sit down and talk with Paul about some of the weird experiments he's done with the convergence of two things. One, his love for, and I'm quoting him here, super hardcore nerdy math, and Apex, as well as some other parts of the platform. Also, at some point, we start talking a lot about pigeons. But to kick things off, we go back to that cold quote and talk about the programming languages he was learning to make that game.
Yeah, so got going into computer programming, started off with things like Dark Basic and Blitz Basic and, some of those variants. And then took a weird dark twist down into learning Perl and C. And I can't remember any Perl now, so please don't ask me any because Perl's the worst language to learn for a starter language. It's awful. Everything's a string and nothing makes sense.
Yes.
So that was it. So went down that route, was doing it. The CTO at Cloud Galacticos, where I am now, actually was a guy I worked with when I was just prior to going to university. I was helping program the credit card systems at a major newspaper. I won't share which one. Hopefully they're not in use anymore. So the 18-year-old doing that. And then, I went away to university and loved maths and kind of went and did that. And then when I graduated was just about the time that the financial crash was destroying the world. And so all of my dreams of being an investment banker and now being a millionaire on a yacht somewhere were dashed. I actually had an interview for an investment banking job the day Lehman Brothers collapsed. And the guy interviewing me was like, there's no job here, man. Just, I'll give you some free interview practice, but there's no job.
Wow. Wow. Okay, so a few things. I find it fascinating that you have this rarity of a connection in math. However, you also just said two things which have come up before, like I wanted to make my own video game, so I'm going to go learn how to code. And I don't know what the right term is, but we're Perl brothers. That was the first language I actually started coding web applications in. And I agree with you. Not the best way to go.
I had a really thick, book, which was Perl web applications with CGI in easy steps. I swear it was something like that. But this book was 4 inches thick. And it was, I just remember being 14, 15 and my dad just saying to me, what are you reading? And if that's easy steps, surely you need to go and do something else.
Cool. Okay, so I am personally terrible at math. And I do think it's kind of funny because the whole conflation thing, people are like, well, you're good at programming, you must be good at math. And I'm like, no, I'm always around a supercomputer that's good at math. And I just ask that question, like what's that? So for a non-math person like me, can you explain what the no cloning theorem is?
Oh, so first of all, no one's bad at maths or math. Everyone's really good at it because I would bet you a beer next time we see each other, Josh, that if you go into a shop and you're given the wrong change, you can say that pretty quick. Or if you were outside, I don't know if you've got kids or if you and I were outside just throwing a football to each other, you can figure out how to catch that football.
Sure. And
that's like doing advanced equations in your head. It just so happens that you're not sitting them down and writing out the numbers. So no one's inherently bad at it. I think people don't like it because it's abstract and badly explained.
Okay.
So that's kind of so I have this thing where everyone's good at this, everyone's good at everything in my mind.
Yeah. Okay.
You just need the right kind of context for it. And so the no cloning theorem was that was what my master's thesis was on. I'm wondering where you dug that up from.
It might just so happen to be on your LinkedIn.
Oh, there we go. Okay, get you LinkedIn scouring. So basic idea is that there's this weird thing that quantum particles do called entanglement. And if you entangle these two, photons or whatever, and take them as far apart as you want, they can transfer information. Or the idea is that they can't transfer information. So if you change one, the other changes instantaneously. But the argument there is, could you communicate faster than light and blah, 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 which Einstein did not like. And so the no cloning theorem kind of uses the same kind of principle of entanglement to help kind of show that you can't ever make a perfect copy of a state. So like you can,
Got it.
if you try and copy something, you effectively destroy it. You can get close. I think at the time when I did that, it was like 80 something % good, but like there's no quantum Xerox machine.
Got it. I and this may be a first. I might have to put a Wikipedia link to that in the show notes.
Well, what I hope now is that someone's not going to for anyone who reads that Wikipedia link and then comes back to me and says you've explained that wrong. It's 30 seconds on the podcast. Come on,
Right. Fair. Okay, so we're here to talk about, and I'm using your words here, your weird experiments in Apex.
Yes. I like to do odd things.
Yes. Starting with getting machine learning within Apex. Now, with Einstein out there, is there a practical reason for doing that, or was this just purely like for the challenge?
So this predates Einstein.
Okay.
I'm going to claim and hold to the fact that I was the first person to talk about machine learning with Salesforce.
Okay.
If Mark Benioff wants to take me out for a nice meal and discuss it, we can do so. But I am going to hold on to that fact. So,
okay.
Yeah, I was looking into I was just doing like a machine learning course on Coursera. It's the Andrew Ng one that everyone has done.
Okay.
It's really, really good. And yeah, just was doing that and happened to talk to a coworker at the time who said, yeah, but you couldn't do that on Salesforce, and was whinging about how bad Salesforce was. I was like, yeah, you could. And so because someone said that I couldn't, I went and did it. And myself and a former colleague of mine, Jen Wire, who also has a background in maths, so, two math programmers, we went and built a machine learning system in Apex that did what's called k-means clustering. So it's like grouping things together.
Okay. So kind of like the no cloning question, can you explain machine learning to me like I'm 5?
Yes. So machine learning is basically, in fact, I've got a fantastic story I read about this the other day. So they started teaching pigeons. There's some company that taught, or some group that taught pigeons to identify spots on brain scans or MRIs for tumors. Yeah. And so you'll see where I'm going with this and how this gets back to machine learning in a minute. Because obviously the valley is now going to be flush with pigeon-based startups. But the idea is that you just show a pigeon a bunch of pictures and it gets a reward for tapping on the right spots on the screen. It doesn't know what it's doing. It just knows that if it taps the right spots, it gets a treat. That's all machine learning is that you are showing a machine a bunch of pictures, and every time it gets it right, you're saying, well done, machine. Now have another go and see if you can do better. And it just does that. And so there's a load of very odd kind of mathematics and matrix algebra and all these things behind it. But at the end of the day, if you can get the idea that you show a pigeon a bunch of images and the pigeon gets a reward for tapping the right spot, that's all your machine learning algorithm is doing. It is just giving a machine lots and lots of data, telling it when it's hitting the right spot and giving it a reward, and the machine coming back and then trying again and again and again.
Gotcha. So I love that you use the pigeon example because it segues brilliantly, I think, into this next question, because there's machine learning and then there's old school sci-fi AI, HAL 9000, and you're not trying to make Apex sentient, right? Those are two very different things. Yeah,
they're very, very different things. So machine learning is like a subset of AI. AI is a very catch-all generic term, like analytics, what does analytics mean? And that's I'm sure there's an A that will somewhere tell me exactly what it means. But it's a very generic term. So artificial intelligence as a term is just having a computer perform a task like a human without necessarily being told the exact instructions.
Gotcha.
Whereas machine learning is a specific implementation of AI where it's show it a million examples and let the machine try and guess. And that's only it was actually very popular back in the 80s and earlier on than that, machine learning, but kind of fell out of fashion because everyone realized that they had very, very low power computers. And then suddenly we have this thing called the cloud now where you can process hundreds of millions of things over and over again. And so it becomes a lot easier to show. And it's also the volume of data as well. It's one of those things with I had a customer I was working with not that long ago who had 1.3 million contacts in their database.
Oh, wow.
And it's that sort of thing that if you were to think like when you first started working with IT systems, how many databases did you see of 1.3 million contacts? And this wasn't like a Fortune 500 company or FTSE 100 company.
Right.
This was a charity. It's like crazy.
Right. That's actually interesting. I'm kind of like slapping myself on the forehead because I, having evangelized Einstein and all of this kind of stuff, it's like I saw the cloud as a convenient delivery system for machine learning, both in the intake and the output, right? Because it's just your browser at that point. But it honestly never occurred to me that the pure, like the depth of both the CPU potential and also the depth of data just mirrors up to what machine learning needs right away.
Yeah, well, there's that, I'm going to get this statistic wrong, but I think it was that 1 billion hours of YouTube are watched like every day. Or 1 billion videos or something. There's the number 1 billion, I'm pretty sure it's hours of YouTube are watched every day. And that's why YouTube's algorithms are so good at giving you the next video of whatever it is you want to see. Is because they've got that. I mean, like, say they worked on what? 1% of that data? That's 100 million videos for them to churn through every. Yeah, it's a lot.
Yeah. It's a lot of pigeons.
It's a lot of pigeons.
Okay, so you have 3 blog posts that I read up on this for this interview, and the first one discusses and goes into the math behind using matrices for machine learning. It's a podcast, so we can't really get too deep into the math, and I don't know how much of it I was following anyway, to be honest. But tell me why was this your first step? Like, where do matrices fall into the tool set of creating machine learning?
So I think I've just realized as well that when we're talking about math here, I've just said that 100 million is 1% of a billion. So like, let's just, I think it's also when people say you're good at math, just to go back to our earlier point, they think good with numbers. I can't add up. It's a running joke in my family. Like, if I'm at a restaurant with you and you ask someone to split the bill, do not ask me to do it. Like, I would rather pay the entire bill than be asked to split it. Numbers are not my thing. Squiggles on pages, I'm good with. So there you go.
Gotcha.
Like catching your own bad arithmetic. So we're talking about matrices and machine learning. So the reason it comes together is that if you think that effectively what you're trying to do is you're trying to solve a big bunch of equations at once. Mm-hmm. You're trying to say, if I have these 10 inputs and I want to give 10 outputs and they're all connected to each other, how do I multiply them together to get that right value? Okay. And that's where matrices come in. So it's a part of linear algebra for solving multiple. I don't know if you've ever come across some people have come across simultaneous equations. The standard high school one is you have 5 apples and 4 oranges and it costs you $3.50, and your friend buys 2 apples and 6 oranges and it costs them $2.90. How much is an apple? How much is an orange? Mm-hmm. And you obviously can write the equations down together and solve that. What you're doing with matrices and with machine learning is doing that, but with I have apples and oranges and bananas and pears and every single fruit you can think of. Right. And I also have their colors and and their weird other factors I've got going on. Mm-hmm. And I've got me and 50,000 of my closest friends to tell you how much it's cost for us all to get these things. Please work that out.
Yeah, gotcha. So it's kind of like a super dimensional grid of all the things that you need to point pigeons at. Okay. So then in the second post, you're talking about linear progression, and I think I'm guessing where this is going, but mathematically, where does the linear progression then delve into the matrices?
Yes, so linear regression. So if you think about standard thing is height and weight, right? Uh-huh. Typically, someone who is 6'8" is unlikely to weigh 7 stone, or I don't know what that is in pounds, they're not going to weigh that much. Whereas someone who's 4'5" is not going to weigh 30 stone. Mm-hmm. And so there's a definitive correlation between height and weight. If you plot all those points out on a scatter graph and then just draw a line of best fit, that's called linear regression, where you're just trying to find the one line that goes through it in the best way. And that's really easy when you're thinking of 2 dimensions. You're thinking of height and you're thinking of weight.
Yeah.
But if I said to you height, weight, and age, now you could plot that again as like a best fit kind of plane it'd be. So, if you imagine like almost a sheet bended out in different shapes to do it. And you've got to find, and what you want to find is you want to find where that fits best. And then, that's really easy to do in 2 dimensions because you can see it. In 3 dimensions, Excel could draw it. What if, again, we get up to like 17 dimensions? I remember one morning walking into a lecture hall and it was 9 a.m. Like math students always get the worst lecture times. 9 a.m. I was a student, so, I'd been out the night before, hadn't got a lot of sleep, sat down, and the lecturer was like, okay, so let's start off by imagining a 5-dimensional sphere. And I just, at that point, I think like it was, I knew just that. Done. Yeah, the lecture was, I don't remember anything else.
Nice.
I had a friend whose notes I used afterwards, but that's it. Like humans are very bad at visualizing all these different things,
right? And
so that's where like the matrices come in again. Is like helping provide a framework for the computer to do that,
for pushing things through. So if I'm following this right, the matrices are the boxes that we're going to put the pigeons in front of, and then the linear regression is the means that you can determine if the pigeons are actually poking at the right dot.
Yeah, that'd be a fair way to put it. So the matrices are really all of the images that the pigeons will look at.
Right. Okay.
And then the linear regression is saying how good is our pigeon doing? And then over time, our pigeon will get better and better at guessing. And you want to try. What we're trying to do is minimize like the deviation. So if you were to imagine that simple like height and weight chart again. Yeah. Like you can think of the line of best fit because you can intuitively see it. Yeah. But like if you were to tilt it one way or tilt it the other, the error you would have on average goes up because you're just drawing a silly line somewhere. So what we're trying to do is minimize that line and minimize that error. And so we're showing all these pictures. Our pigeons are guessing correctly, and we're finding out how good the pigeon can get and trying to get the pigeon as best as we can.
So speaking how good the pigeon can get, how successful were you with this experiment?
So we got it running. There was a Dreamforce presentation. Like all Dreamforce talks have to end with success. I'm pretty sure. Like I think at the time it was back in 2014. So someone like Reed or yourself would have probably been vetting them all in the background.
Yeah.
And at that point, if you'd have seen like doesn't work, no. Pull that one. It worked. We took a bunch of data from the United Nations, ran it through, and we were able to kind of reproduce a clustering of kind of countries by different development factors. And it was quite interesting because we had some things that showed up the same as like the UN's own data, and some things that showed up that were like, that's interesting. So, yeah.
Nice. Awesome. Well, let's move on to another experiment of yours. And I guess this is a little bit more front-endy, but there's definitely obviously some Apex involved. But you also put together a virtual reality experiment with, this is going back to the day because I believe it was in Visualforce. But what led you down that route in the first place? Like what got your interest in VR?
So VR was like, it was, this probably is 2016, 2017, maybe
2016, I think it was, yeah.
Yeah, something like that. So VR, VR was just coming out then. Like the PlayStation VR wasn't out. Oculus had a dev kit just out at the time.
That's right, yeah.
And, those things were super expensive. And so I was like, well, there's got to be a way of doing this, because Google came out with the Google Cardboard.
Right.
And so, super cool bit of tech that cost $3. Mm-hmm. And so I had one of those, had an iPhone or an Android, I can't remember at the time, and it was working, all good. And I was chatting to another colleague of mine at the time, Vincent Reeder, and I was saying to him, it'd be really cool if you could do some VR stuff. I wonder if you could do it with Salesforce to visualize things. Mm-hmm. And then he said to me, yes, we should build this. We should submit it for Dreamforce. And have you read Ready Player One? So I then spent the weekend reading that. I was like, should we build the Oasis in Salesforce? It's like, no, let's wind ourselves back. So it was Visualforce, 3JS, and it was platform events as well, which were...
Oh, was it really?
Well, no, not platform events. So it was the streaming API, which is obviously slightly...
precursor.
Precursor.
Yeah.
And so we had a demo where we had all these people in the kind of lecture hall or theatre, and one of us was wearing the Google Cardboard. We had like a beach scene that you could see around in 3D, and we had a web page, a sites page that people could go in and just press a button, and it would create a record as the guest user, and that was connected to the streaming API. And every time the Comet D interface received an event, it would create a firework. So we had these fireworks just going off around in your head based upon people and so there was quite a nice thing where at the end we basically said, all right, we got like 5 minutes for questions, but we're just going to stand here and anyone who wants to play. And so we just had this queue of people. No one, I think, this was before they were really recorded, so it worked out well.
Right.
Nowadays, there'd be a guy at the back on the AV just telling me to shut up. But we just had this. It was great. We had a queue of people. They came up, were playing with the cardboard.
Nice.
A couple of questions, but it was also quite nice and simple tech. The streaming API, nice and simple. Comet D isn't the easiest thing to set up, but it's not too awful. And it was just some nice records coming in, and that was it. And there was a couple of really good VR demos that year. There was one company who were doing almost like stack of cylinders where you could go and choose different records and view opportunity data and things like that. And I think that's the it's one of those cool, fun things. Like Vinny and I just enjoyed working on it because we just enjoyed working on it. It made my mobile phone, my cell phone overheat. Genuinely could not put that in my trouser pocket because it was burning my leg.
Oh my gosh.
And drained the battery beyond belief. There's no use case for it. There's no standard Sales Cloud VR use case I can think of.
Right.
Product visions and things like that, maybe, but no AE is really gonna use that and run it from their phone. But it was cool.
Yeah. And that was that's kind of my follow-up question, because I remember people putting 3D analytics together. I somehow failed to see I honestly thought I was the person who put you on stage, but I don't remember fireworks. So
there you go.
So either I was and you got that past me or what. But then also storefronts, like a virtual store, people could kind of walk around. I remember one you could rotate an engine so that you could see a product that normally you wouldn't be able to hold in your hand, kind of thing. But what I find at one point I thought the inflection point for VR was going to be that, right? Like big business will throw money at VR, and Oculus will do a enterprise grade headset that the normal consumer isn't going to buy. But the guy at GM who needs to work on the engine, he's going to put a VR headset on. But it feels like we've gotten the opposite, right? It's like we have PSVR, we have all these VR gaming has having a heyday right now, and it feels like enterprise VR just kind of fizzled out. Where do you think this is going?
So I think the reason that gaming kicked off earlier is because it's such an easy mass market for people to go for. So I don't know if on the PSVR there's a game called Vader Immortal, and it is done by what was formerly LucasArts.
Yeah.
And that game, if anyone has a virtual reality headset and wants to just play an amazing experience, it's that. It starts with you jumping out of hyperspace in a ship that you're in the cockpit and can see all around. My fiance came down and says what are you going wow about? And I've just stood there going, oh my, and they knew what they're doing. They had Vader it was with the ILM team, and so Vader's always above you.
Yeah.
So doesn't matter how tall you are, and if you stand up, Vader's always looking down at you, and he's a big menacing. It was really cool. Nice. That's an easy, good experience to do in VR.
Right.
Whereas I think the problem with the enterprise level is it's the cost barrier to see it, because training is a good example. I used to work with a load of pharma companies. And I could see it for surgeon training and all of those sorts of highly detailed niches. But the accuracy is not. I mean, if you've ever used any of the VR handsets, the accuracy is not there for There's a reason that Surgeon Simulator on all of these VR games is about you accidentally killing people on the operating table. Yeah. So if you can't do that level of dexterity, it limits the things you can do. And
yeah, that's fair.
And I suppose it's that thing of for that cost barrier,
Mm-hmm.
Like, because there was a big one was like, I think it was BMW or one of the German car manufacturers were saying you could like sit in a BMW and like style it how you. If I'm spending £30,000 to £40,000 on a car, I'm going to sit in the damn car.
In the car, right?
Yeah. Like, and that's the difference here. Is like,
Yeah.
And so I think I can see there being more in the enterprise in the future. I thought HoloLens or Google Glass was going to be it because I can see it being an augmentation. Of your view, but like I can't see it being a complete VR setting. Yeah,
and I feel like Microsoft agrees with you. Like they seem like they're pushing ahead with HoloLens.
Yeah, they gave me a call just to check what I thought about it for them.
I love it. Okay, so talking a little bit more about Weird Apex, you also have a series of short videos talking very specifically about performance in loops. And I kind of love how detailed you are in them because they're very, like, you're very specifically showing apples to apples and the distinctions between the apples and what happens there. And my first question, like, one of the first things you do is, like, in an iterator that's going to track array.size, you move that array.size into its own variable, and then you iterate against that, and you show a pretty significant increase in performance in that. And I'm just like, why? First of all, I'm surprised. I've never tried that, I guess because I just never really assumed it would be that much of an increase in performance. But why is it? Is it just simply that size is that slow?
So I think, well, it's not that slow. It's the scale of it being that slow. Like, and that's, so the loop videos were actually, they came first, and then I did the machine learning talk, because the machine learning stuff just uses that and batch Apex in the background. I'd love to tell you it was something super cool. Like, but yeah, we were running loads of batch, like the demo at Dreamforce.
Yeah.
We basically got on stage for a 40-minute presentation, like, okay, we're going to start the demo now. Just watch what we're doing, and because, like, it's Dreamforce, you don't know if you're going to be able to run 2,000. I mean, because some of them are like 2,000 batches in a run. And it's looping through because to do all the maths. But yeah, so we were using that. But the kind of reasoning behind it was that, like, I'd realized that I'd got overly comfortable with, like, the nice syntactical sugar for loops that Salesforce gives.
Yeah.
So the for account A in, and here's my SQL query, and I'm off.
Right.
And it was one of those things that I got back into doing more JavaScript and was just like writing these loops the other way. I was like, I wonder if they're faster. And just one of those things that came up, and then I saw the change. I was like, oh wow, this is a lot faster. So yeah, and I think that's it. Like, if you're doing a loop over 200 records, this isn't going to make that much difference one way or another.
Got it.
On things, but like when I was starting to think about 10,000, 20,000, you could be iterating over like thousands of things.
Got it.
It makes a big difference.
So, do you have a feeling for where that tipping point is from 200 to 10,000? Like, when's it really going to start making a difference?
This is where, like, I give the consultant's answer of it depends. So like so I recently did a talk at London's Calling, and like there's a section in one of my books just on this kind of whole performance stuff.
Okay.
And like, that's a detailed description, performance stuff. Sorry for the jargon, folks. But like, there's so many things in Salesforce that you can make fast or slow. Like, I'm going to say, like, Flow, Process Builder, they're going to slow you down. Like, it's nothing. I don't dislike Process Builder and Flow, but if you add a ton of them in there, you're going to get 5-10 second wait times for a save. Like, that's life.
Yeah.
You're going to be able to build things a bit quicker, but
such a trade-off. Yeah,
exactly. And the trade-off is the key thing here. Like, if you do that different for loop, you're going to end up taking up heap size. Now, the trade-off really is not kind of just where you're going to notice it. It's what are you doing within that for loop. If you're just doing something dead simple, it's not going to matter. Like, it's going to be milliseconds.
Yeah.
But if each one of those for loop iterations takes half a second or 100 milliseconds, that's when it adds up. And one of the things, like, I try and focus on when I'm talking to people about performance is that I love sitting and looking at graphs and getting nerdy, saying like, look, here's a parabolic curve, and here's like,
right.
In that book, I go into like big O notation analysis and all sorts of stuff like that. But at the end of the day, does the user notice it and does the user care? Like, so heap size is a great example. If you said to me, Paul, you've sped up the CPU processing by, say I've taken it from 5 seconds to 1, but I've gone from consuming like 5% of my heap size to 65% of my heap size.
Mm-hmm.
That's fine with me because my end user doesn't care about my heap size. I mean, I'm assuming like Chris Peterson or someone back in Salesforce Towers is probably sat there going, what's he doing? Why is he doing this? Getting very angry with me. But like my end user is going to notice 5 seconds down to 1. They're not going to notice whether it's like 2 megabytes or 2 megabytes or 4 megabytes of heap size. They don't care.
Right.
And so, and that's I think the thing here is like, as you say, it's trade-offs, but it's also understanding what really matters, which is what's the user going to notice.
Right. First of all, I know Chris well, and I think it's true. He does take other people's code very personally. Just kidding. But okay, and I'm going to ask you what probably sounds like a sort of on-the-nose question, but I'm asking this because like back in my Visualforce workshop days, I knew there were a lot of people who knew Visualforce but didn't like know what a view state was. So define heap size for me.
Oh, heap size is the amount of stuff you have in memory. Is my simple explanation. I do like when I'm doing the Salesforce training things, it comes up and you can either go into a really deep dive or like simple answer, the amount of stuff in memory at the time, like that you've got called up.
Well, and I think that's an interesting comparison because like that's also sort of the best explanation for a view state, right? Like it's like this is the amount of stuff that your client and server need to talk to each other about. And the less of there is, the faster your page is going to be. And I think that might actually answer my next question then, because the next thing you do is move an array into its own variable and then reference the variable. Is that changing the heap size? Is that why that's faster?
Yeah, so that increases a lot of heap size, but it takes up more heap size, but has a change in your CPU performance, and that's again this seesaw of like obviously if you end up going over the heap size, that's also a governor limit, but
right.
Are you going to?
But are you going to? Well, and I think I'm trying to remember if it was in these videos or in one of your blog posts, you had a really good analogy that's like governor limits are there to kind of like keep Salesforce safe. They're not a predictor of performance, right?
Yeah, that's like you shouldn't, because you've got 100. That's not 100 SQL queries is not a target. Like that is a limit, not a target. Like same with like the heap size is the only one that is so different because it's just like the only time I've ever hit the heap size is when I'm messing around with blobs.
Right.
Like it's such a weird, and like, Apex is obviously, for want of a terrible phrasing, is a DSL on top of Java. Like, I know it's not, Chris, I'm so sorry if you're listening to this. But like Apex compiles down to like Java bytecode. It's great at memory management. Like the JVM, whilst it takes forever to spin up, once it's spinning, it's fantastic at keeping memory clean.
Right. It's good at spinning plates.
Exactly. And that's the same, like you're using that same memory engine effectively under the hood. Like it's going to be really good at cleaning things out. And there's also some little hacks you can do where if you want to clear something, set it to null. Yeah.
Right.
It'll reassign the address. Jobs are good.
Yeah. It is. I mean, data management comes up so many times when we're talking about like how fast can we get X actually done. Now, that video was followed up by something I've personally found delightful because apparently you got into a Twitter conversation about what you were doing performance-wise. And then you had like Anthony Fawcett, Andy Mahood, and who was the third? Stephen Herod. You had Stephen Herod, all like being like, "Well, what about this? Like, is this faster? Or what about this? And is this faster?" And I'm going to leave as homework to our audience to go watch that other video because I think it's a fascinating just match of really, really smart people offering really smart designs kind of things. But I will just note, I am not surprised that the most complicated offer was from Andrew Fawcett.
No, Andy. Andy was my first boss when I started learning Salesforce.
Really?
Yeah.
Oh, nice.
So Andy and I used to sit, I don't know, like 15 feet from each other. Like Andy taught me a load about Apex.
Wow, nice.
And is one of the smart. Like I was very, very lucky that when I started out, I was learning from him and Stephen Wilcock, who's still at Financial Force, and Carolina Ruiz, and just a bunch of super smart. Like there's idiot me. And like just all these clever people willing to give me like time to talk through stuff.
Right. And obviously I'm kind of jabbing Andy a little bit in the ribs. He is one of the most brilliant people I've met.
Oh, yeah.
And while complicated, I do think it's just like he's a brave enough programmer to be like, just have your own iterator. Just try that.
Oh, yeah, like, so having worked with Andy a lot, like, so Andy's obviously the father of the Apex patterns and like all that stuff that comes in. I'm one of these people that I look at them and I can see everything that's in them. I'm like, that's too much code for me to add. Like, I'm a lazy programmer. Keep it lean, keep it mean. Mm-hmm. But I know I can see the value in them and see like, and Andy's exceptionally smart at coming up with that sort of stuff. And it's, I mean, it was no surprise when he made the leap to the mothership because like you guys have got yourselves just a super person there working on stuff. Yeah. And Andy, if you're listening, we're very happy to have you. So, okay, now you have literally written the book, or actually technically books on this. What books do you have out there, and where can people get them? So all good bookstores, but primarily Amazon because everyone gets everything from there nowadays. But yeah, so I spent my lockdown doing 2 books on Apex because I couldn't go anywhere. So the first book is called Learning Salesforce Development with Apex. It's kind of an intro book to Apex. So if you're an admin looking to learn Apex or a brand new developer to the platform, like it's designed for you because, you know, when we started and we were saying about like learning Perl and learning C and learning Java, like when I first started learning Apex, every piece of the documentation was like, just like Java or just like .NET. And if you don't know Java and .NET, that's not helpful. Right. And so it's kind of a ground up. By the end of it, you are calling a web service and doing all sorts of cool stuff like that. So it's going to take you all the way through that. And then one of the fun things you find is you're writing a book like that where you know that there's a definitive, I can't go past this, is you then go, but I want to talk about all of this other stuff. So the second book is called Mastering Apex Programming. It is for intermediate developers. So if you've got sort of, 3 years plus, hopefully you can learn something. Like, I have to give a big shout out to Mike Gill, who was the technical reviewer on the book. I'm lucky enough to work with Mike every day, but he gave so much good feedback and was really good at saying like, I learned something from this, or I'm going to tell you need to add this in.
Right. Gotcha.
So yeah, which is exactly what you need. So yeah, so it's nice. And it goes through different sections of, if the first one's very much almost like a how to program book, but specific to Salesforce. Mm-hmm. The second one's more like, okay, this is a bunch of stuff on common errors and how you get rid of them and how to debug properly and use the tools. How to, just do stuff that people perhaps are like, how to write unit tests and how to use those unit tests to help you debug effectively. Got it. And then we go into asynchronous Apex, so all of the different flavors, how and when to use them. Again, if someone like Chris reads it, I'm sure they'll go, not sure about some of these, but my own experience, I would caveat everything that's in every book by do your own research. Like, right. And then the last section is all about performance. So it's some of the things that you talked about with like the loops, but I also get into query performance, different bits and pieces like that. How the Force.com optimizer works, and then like some impacts that architecture can have on it.
And that's our show. Now, in the show notes, we will have links to Paul's books and the various talks and presentations that he's done. Now, before we go, I did ask after Paul's favorite non-technical hobby, and it turns out it's one that we both share with a lot of developers.
I mean, it's going to be like probably playing on my PlayStation when I get the time. It's a ever dwindling amount of time. But I've got a couple of good friends. We play regularly, a bit of Ghost of Tsushima and a few other games together.
Oh, brilliant.
Old school friends, old university friends,
nice.
Just abusing each other for a couple of hours whilst, letting out some steam. So it's good fun.
I want to thank Paul for the great conversation and information, and as always, I want to thank you for listening. If you want to learn more about this show, head on over to developer.salesforce.com/podcast, where you can hear old episodes, see the show notes, and have links to your favorite podcast service. Thanks again, and I'll talk to you next week.